You can visit our website if you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. Hi everyone, today we will be learning about IP related question, most probably IPv4. IP calculations has bigger scope in CCNA exam. For example, they can ask you the direct IP related question, or else they can combine the IP questions into another topic. For example, they can question your knowledge on IP through routing, VLAN, access list or NAT. Knowing the IP calculations would bring you more credits on your exam, as well as in the real life you can save a lot of time. There are mainly 5 kind of IP questions are involved. So if you learn these 5 questions right, then you can deal with any IP related questions. As a beginner, you might not know about even the terms in the 5 types of questions, but I'm sure in the end of the session you can answer all these 5 types of questions. There are many methods introduced for the IP calculations to do the calculations by using certain tricks. But remember one thing, if you follow any tricks without knowing what you are doing, then in the end it's not going to help you. For example, you can simply use a trick to get the answer, but when the question format changes, you might get into trouble. For that purpose, you just wanted to know where you are applying this IP in a real life environment. Okay. So before you begin the IP calculation, you just have to know certain terms related to the IP calculation, so that it would become easier for us to answer all the questions. First of all, you need to know why we are using the IP addresses. The purpose of networks made in order to communicate with one another, right? So for each and every network device, we are assigning certain IP addresses, kind of names. For the CCNA exam scope, we just have to know about the IPv4 calculations. In our calculations, we just have to know where and why we are using the switches. We are using the switches to connect certain devices on the same network. So when you connect these 5 PCs to the switch and assign IP addresses for these 5 PCs on the same network, then they all can communicate with one another. So switches are used to allow the communication between same network or same subnet. Okay. So Cisco switches will have around 16 ports, 24 ports, 48 ports or just 8 ports. Likewise, there are certain number of port differences between each model of switches. Okay. First of all, you need to know IPv4 addresses are 32-bit addresses which are divided into 4 parts. You will call these parts as first octet, second octet, third octet and fourth octet. Okay. Consider all those are like 4 columns. The first one is first octet, the second one second octet, third one third, fourth one is fourth octet. The IPs fall like your digital clock. You can take the seconds column and minutes column. So you just know that there are 60 seconds in each minute, right? So the seconds column in a digital watch, it flows as 0, 1, 2 and likewise it goes up to 59. Then we won't get a 60. For after the 59, it will turn into 0 again and the minutes column will become 1, right? Likewise, after that minutes column becomes 1, it will again move from 0 to 59 from the seconds column until the minutes column become 2 when the 59 second passes, right? Then again the process repeats and the minutes column will reach up to 59, and still the seconds column will become 0 to 59, and after both minutes column and seconds column becomes 59, column will become 0 to 59, and after both minutes and seconds column becomes 59, hours column will turn into 1 and the minutes and seconds column will remain in 0, right? So likewise, our IP addresses are going to flow from 0 to 255, like 0 to 59 for the seconds. Here the IP addresses on all the columns, the maximum you can fill with 255, okay? So 0, 1, 2 and 255. When it reaches 255 from the fourth octet, the third octet becomes 1 and the fourth octet becomes 0, right? Again, the third octet still remains in 1 until the fourth octet goes from 0 to 255. Likewise, after the 255 on fourth octet, the third octet becomes 2 and it goes up to 0 to 255. Then again from 3 it goes up to 0 to 255. Likewise, until the both third and fourth octets become 255. The second octet remains in 0, right? So once after both the third and fourth octet becomes full, like 255, 255, then the second octet turns into 1 and the third and fourth octets becomes 0, right? Then likewise the same process repeats until you get all 255 for the second, third and fourth octets. Then again the first octet turns into 1 and the remaining will become 0, right? After that what happens is 1, 0, 0 and the fourth octet goes from 1, 2, 3 and up to 255, and again the process repeats from top to bottom as I shown here. You can see that, okay? So most of the mistakes the students make in IP calculation because of the misunderstanding on the IP flow. So if you have doubts on these portions, just revise it again, then move further. Finally, the IP addresses reaches all 255, which is a broadcast address by default, which means 255.255.255.255. For these calculations, just imagine switches are representing the networks and hosts are representing the number of end devices or printers or PCs. So generally, if you take a company, it might have IT, management, maintenance, HR, sales, accounts, law, and more departments. So for each department, we can assign IP addresses from particular network so that the particular devices on the network can communicate with one another. For example, the particular host on that particular network can communicate among them. They can't communicate from the particular network to the other network. Okay, there are some other features we can make communication among them, but for the calculations now, just imagine this is the reason we are doing. For example, let's say your company is having a department in IT and another department called accounts. So whenever you assign end devices in the IT department with a particular network, and for the accounts department you are assigning a different network's IP addresses, so that all the PCs on the IT department can communicate among them. The PCs on the IT department can communicate among them. Also, all the PCs on accounts department can communicate with or in accounts department. But the PCs on IT department shouldn't communicate with the PCs on accounts department. Okay, so these are the purposes we are trying to do the IP calculations. For example, let's say you are having certain companies like this. One company which has very less amount of departments, but in each department of the company has many network devices involved. In another scenario, consider a company like this. There will be more departments and more hosts on each department. And in another scenario, you can consider a large company which might be having a lot of networks involved, but in each network there won't be that much of host attached. So based upon these scenarios, we can't fix any company to have a particular amount of network or particular amount of network devices, because time to time their network requirement might change, their host requirement might change. So for that purpose, on our IP address itself, the 32-bit IP address itself, we are representing which is the network portion of this IP address and which is the host portion of this IP address. So to label the network portion, we are using ones, and so as shown here, we can mention among the 32 bits. Here I have mentioned the first 8 bits are ones, which means I am specifying these as the network portion, and the remaining second, third and fourth octet bits I have specified as zeros, which means here in this IP from first. So here in this IP address, the first octet belongs to the network portion and the remaining 3 octets belongs to the host portion or end devices, like that. For example, let's take an IP address 10.5.20.50/8. The /8 represents how many network bits you are having in your IP address. For example, the first 8 bits are going to be the network bits in this example. /8 means the first 8 bits. If you have /16 here, then the first 2 octets going to be filled with ones. So you can simply imagine here in this network you have ones filled in the first octet. So /8. If you have /24 here, you will fill these first 3 octets, which means first 24 bits you are going to fill with ones, and the remaining 8 bit will remain as zeros. Okay. So likewise, in this example, in the network portion, the first octet, if you change any number in this first octet in the network portion, for example, if I change this 10 into 11, if I go for 11 dot, then I am in a different network than the previous network. So 10 dot and 11 dot are 2 different networks. 10 dot and 20 dot, 13 dot, 14 dot, everything that starts with a different number on this particular octet will take you into a different network. Okay, but if you are still remaining in the 10 dot and if you are changing the host portion, for example the second octet or third octet or fourth octet, you can change from 0 to 255, anything. For example, if I change this 5 into 20 or 25 or 30 or 250, whatever, but this is in the host portion, right? So 10.50.20.50/8 will still remain in the same 10 dot network. Okay. Okay. So if I change this 10.5.200.55, then still I'm in the 10 dot network. If I change the last octet, for example 10.5.20.254, still I'm in the same 10 dot network. Okay, so just remember these points. If you change anything on the host portion, you will still remain in the same network. But if you change anything on the network side, you are definitely in a different network, which means you can't ping from the 11 dot network to the 10 dot network. Okay, you will need a router for that purpose. That's a different topic. We'll learn it in a later session. So now let me modify this 8 into 16. Okay, at that instant you can figure out the labeling of IP addresses are going to be like, for the first 2 octets going to be filled with 1s. Okay, so the first 2 octets are going to represent your network portion. So in the first 2 octets, if you change any IP address, you are on a different network. For example, if I go for 10.6.20.50/16, at that time I'll be in a different network. So for example, let's say now for the 10.5.20.50/16, if I try to write the network portion and host portion, I'll get first 2 octets into 1s and the third and fourth octets filled with 0s. So for example, let's say 10.5.20.50/16. So here the first 2 octets are going to be my network portion and the remaining 2 are going to be in my host portion. So if I change anything on the network portion like 10 or 5, if I change anything on this network portion, I'll be in a different network. So from that network I can't ping or communicate to this network. Likewise, if I change anything on the 20 or 50, which means the host portion, still I will be remaining in the 10.5 network. So there won't be any issue. I can still communicate with the 10.5 PCs. For example, let's say 10.5.20.50 and 10.5.80.45. Both IP addresses can communicate without any router. Just you can simply connect to a switch and they can communicate, because they both are remaining under same network, which means the /16 10.5 network. Likewise, let's say now 10.5.20.50/24, which means your network portion is 10.5.20. So this is the network portion. So here if you change anything on the network portion, then you can't communicate from that network to this network. For example, in our previous example, I changed the IP into 10.5.80. Right? So here if I change it now in my network portion, if I change 10.5.80, then I can't communicate from the 80 into this 20, because my 10.5.20 is a different network and 10.5.80 is a different network. Why? The first 3 octets are now in network portion, which is what represented by the /24. Altogether the IP addresses are 32 bits. So we have divided it into 4 portions. So each portion is having 8 bits. So first 8, then the second 8 is 16, the third 8 is 24, likewise. So the /24 represents your first 3 octets are going to be in network portion. Okay. Okay. So if I change anything on the host portion, if I change this 50 into 100 or 255 or 254, whatever, then I can still communicate with the 10.5.20.50. Why? If I change anything on the host portion, still I am remaining in the same network. So if you wanted to fill these 1s and 0s, then you can simply have a look at this one. So first 2 octets are filled with 1s and the remaining are with 0s for /16. For /24, first 3 octets being filled with 1s and the last octet being filled with zeros. Okay. So as per our previous example, we saw from company to company the network requirements and the host requirements are going to be different, right? So let's say if you have a small amount of network requirement. For example, you are having a few departments and few networks you are requiring. So at that time you can go for the /8 network, which is called a class A network. And let's say if you wanted to increase your network, if you wanted to further increase your network requirement, then you can go for the /16. So in this case, just note down, for /8 your first octet is filled with ones, which means the first octet is used for the network. So altogether 8 bits means 2 to the power of 8, which means 256 networks you can have. Okay. So when you move for the /16, 2 to the power of 16 networks you are having. Okay. So as a result, when your network increases by this amount, your host requirement goes low, right? When you move from class A to class B, /8 to /16, your network increases. Likewise, similarly, at the same time, your host requirement is going low. Okay. So likewise, when you move from /16 to /24, your network requirement is getting increased in a large amount. At the same time, your host requirements are getting reduced. So in class C, you will have a lot of networks, but at the same time, on each of the networks, you can have few amount of hosts. Okay. In class B, you can have equal amount of networks and equal amount of hosts. In class A, you can have very few amount of networks, but a large amount of hosts on each network. Okay. So for example, in 10 dot, you can have from 1 dot to 254. So just have a look at this here. For example, when you are having class A, which means /8 means, you can represent it simply by n dot, n dot, n dot and h, which means your first three are representing networks and the remaining is representing hosts. Okay. So network side, if you change any bit value, you are going to be in a different network. Host side, if you change anything, you still remain in same network, right? So as shown in the picture, you can see in your class A, which means /8, you can have n in the first octet and the h on other 3 octets, which means the n is representing networks and h representing hosts or network devices. So here in the n, 2 to the power 8 bits are there, which means 2 to the power 8 networks you can have. Totally 256 networks you can have. So altogether, to find how many host bits are there means, you can simply deduct the 8 bits from the 32 bits. Okay, which means 32 minus 8, you will get 24 bits for your host portion. Okay, host portion. Okay, so by finding the slash notation, which is called as a CIDR, classless interdomain routing, or we can call it sometimes as Subnet Mask. Okay, so /8 represents number of your network bits. So from that, if you deduct it from 32, you will find number of host bits. Okay, so here we have found that 32 minus 8 is 24. So 2 to the power 24 is hosts in each subnet. Okay, so from each and every network in this address, you can have around 2 to the power 24 hosts. Okay, not only for one network, for each and everything separately you can have 2 to the power 24 hosts. So it looks like, for example, let's say if you are having 2 switches which representing the network means few amount of networks with more PCs, more hosts, okay, more end devices, printers, servers, IP phones, whatever. Then we can move for the class B, which means /16. Again, you know, first two octets representing the N and the remaining we wrote with H. Then 2 to the power 16 bits representing the network. So 2 to the power 16 bits of network you can have in this subnet. Then to find the host bits, you can simply deduct it from the 32, so that you can get the 32 minus 16 equals 16. So simply you can get 16 bits of hosts on each subnet, okay? Not only for one subnet, for each of the subnet you can have around 2 to the power 16 network devices. Here also 2 to the power 16 network devices. Here also 2 to the power 16 devices. Likewise, for the switches, you can again, since it's a class B, you can have again 2 to the power 16 switches, okay? For example, I'm saying. So likewise, when we go for the class C /24, which is represented as n.n.n.h, which means the 24 bits given for the network portion and the remaining 8 bits given for the host portion, okay? So here you can have around 2 to the power 24 networks. For example, let's say if you consider the networks as switches, you can simply imagine you can have around 2 to the power 24 switches connected, and each switch can have around 2 to the power 8 hosts, which means 256 PCs on all networks. On each network you can have around 256 PCs connected, okay? So each PC connected to the switch can communicate with their neighbor switches, okay, which are connected to the same switch, not to the other switches, okay? For example, let's say if you are having a requirement of increment in your network from class A, which means from /A, if you wanted to increase your network, you can do is you can go for the class B. So what you will do, simply from class A, you will change your /8 into /16. By doing this, what is the result? Your network is increasing considerably. At the same time, your host requirements are getting reduced. Okay. For example, if you move from class A to class B, your network will increase. 2 to the power 16 networks you can have. But at the same time, earlier you had 2 to the power 24 hosts in class A. But now, after changing to class B, you will have only 2 to the power 16 hosts in each subnet. So this is a problem for us when it comes for the network design. We can't waste the IP addresses, right? So if you keep this much of network change, then if you assign the network addresses to each switches, some of the networks which might not have that much of PCs, So let's say, for example, if you need only 2 or 3 more networks, then still if you move on to the class B from class A, your network will considerably increase by 2 to the power 60. Okay, why? Because you have changed your network from class A to class B, so the first 2 octets given for the network side, so which results in considerable amount of reduction in your hosts. You can see that. Okay, earlier it was in first 3 octets given for the host side. Now first 2 octets are given for the host side. One complete 8-bit has been reduced and given for the network portion. Okay, so to overcome this issue, what we are doing is we are planning to borrow bits from one by one from the neighbor host portion, like here. Okay, for example, let's say if you wanted to increase your network in a small amount, you can simply borrow bit by bit. For example, in the class A, here if you have 8 network bits and 24 host bits, if you wanted to increase your network, you can simply borrow 1 or 2 bits from the other octet, which means second octet. Here it has been turned into ones from the zeros. Okay, previously it was zeros and now it has been into 1. Okay, so by doing this you can simply figure out /8 here will become /10 now. Okay, why? Your first 10 bits are representing the network portion now and the remaining are representing the host portion. Okay, so likewise, as per our network requirement, as per our host requirement, we need to figure out how many bits are going to be network bits and how many bits are going to be host bits. So based upon this calculation, we are having 5 types of IP calculations. Okay, so these are the IP calculations we are going to deal with. Mainly it focuses on finding the networks and finding the hosts. Okay, they'll ask you in a questioning format in 5 different variety of questions are there in IP. So we'll deal with that one by one. Next we'll have a look at subnet mask. Okay, so if you have /8 in network base, you can write the subnet mask as 255.0.0.0. For /16 you will write as 255.255.0.0. In /24 you will have 255.255.255.0. So here you can note down for each of the complete 8 bits you are representing it by 255. The reason is in 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7, which means altogether 8 bits are there. If you fill them with 2 to the power of, then the value gives you as 255 in total. For example, if you fill all these 8 bits into ones, then you will get the amount of 255. If you fill all these 8 bits into zeros, then you are going to get 0. Okay, likewise by changing the ones value in these columns, you can have any number in between 0 to 255, right? So for example, let's say if you fill the 32 column in ones and 8 column in 1, again in the ones column in 1. So in that case, 1 times 1 gives you 1 plus 1 times 8 gives you 8. So 1 plus 8 is 9. Again 1 times 32 gives you 32. So 9 plus 32 gives you 41. Okay. All the zeros, anyways, even if you multiply the 0 into 128, again you are going to get the 0 as a result, right? So there is no point or no value for the zeros space. So likewise, if you specify all columns with ones, then if you multiply all by ones, you will have these 128, 64, 32, 16, these values only. Okay. So if you add all these values, you are going to get the 255. So which is the value we are specifying in our subnet mask. So we will consider this as the subnet mask, and also sometimes we will represent the /8, /16, /24 also as subnet mask in our exams. Okay. Okay. So if they ask you what is the subnet mask, and in the MCQ they are having a format of like 255, or even if they have the format of /1624 like that, still they are representing the subnet mask, right? So don't get confused in the exam. Okay. My next point is, if you have 16, now you know how to write the subnet mask 255.255.0.0, right? So the network portions are ones as shown here. For the /16, the first 2 octets are going to be the network portion, so we will fill it with ones. In here, first 2 octet, if you fill with ones, you will get 255 here as a result, right? If all the 8 bits are ones, means you are getting 255. So that is the reason we are filling 255 here. Okay. Likewise, the first 2 octets becoming 255, and the remaining 2 For the host portion, we are filling with zeros. So if the third and fourth octates are host portion, you will fill it with zeros, and as a result, if you fill all the 8 bits into zeros, you are getting 0. So you will get 255.255.0.0. Okay. So my question here is, what happens if you borrow bits like this? As I explained earlier, if you borrow 2 bits from the second octates into the network portion. For example, let's say here from /8 we have moved to /10, right? Because our first 10 bits are now network bits. By doing this, we can increase our networks. Okay. So now tell me, how can I write the subnet mask for this /8? For that purpose, we are using a table. I will call this table as bit borrowing table. You can call it any way. Okay. So for example, if I borrow 1 bit on a particular octate, I will fill it with 128. If I borrow 2 bits on a particular octate, I will fill the particular octate value with 192. If I borrow 3 bits, I will fill it with 224. If I borrow 4 bits, I will fill it with 240. Then 5 means 248, 6 252, 7 254. If I borrow all 8 bits, you can remember, if all 8 bits are ones, then I am going to fill it with 255. Okay. This is simple because when you add the 128 with the 64, you will get 192. Again, with the 192, if you add 32, you will get 224. Again, with 224, if you add 16, you are going to get 240. So this table is the addition of this 128, 64, 32 table. Okay. So here in our example, let's say if I consider this /10, here I can see from the second octate, I have taken 2 host bits into network portion, right? So I have borrowed 2 bits in the second octate. So what I am going to fill is, for the first octate, I will fill with 255 dot. For the second octate, 2 bits borrowed, so I can fill it with 192. For the third and fourth, I didn't borrow anything, it's already in 0, so I can mention 0.0. Okay. So my subnet mask is now going to be 255.192.0.0. Okay. If I would have borrowed 4 bits here, I can mention my subnet mask as 255.240.0.0. If I borrow 3 bits, I can mention 255.224.0.0. If I borrow 6 bits, same for the second octate, I can mention 252. For if I borrow 8 bits, I can mention it as 255. If I borrow 7 bits, I can mention as 254. Okay. So to easily calculate all the answers, you must definitely remember this table. Okay. Okay. So it will save a lot of time when doing the IP calculation. So just try to remember it and then further proceed the IP calculation. Okay. So you can simply recall it by 4th bit 240. From that 8421. So 248, 252, 54, 55. For the first 3, you just have to remember anyways. 128, 192, 224. Okay. So now let's have a look at the subnets and networks. Okay. For example, let's take an example of class C IP address 192.168.1.0/24. Okay. So here the network portion is 192.168.1. First 3. Okay. The remaining octate 0 is the host portion. So this 0 increases from 0 to 255. Okay. Still from 192.168.1.0 to 192.168.1.255, still you are on the same network. So all these species 1.1, 1.2, 1.254 up to 255, all these are in the same network. Okay. So when you move on for the 2.0, which means 192.168.2. Which means on your network portion, you have changed, right, by 1 bit. So 192.168.2 dot is a different network. So from the 2 dot network, you can't ping the 1 dot network. Okay. So for the IP calculation, you might know certain things. The first address here, 192.168.1.0/24, is considered as the network address. For the other subnets like 192.168.2.0 or 3.0, all these are network addresses. The first address of the subnet or network. Okay. And the last address of the subnet or network is considered as the broadcast address, which means 192.168.1.255 or 2.255 or 3.255. All these are considered as broadcast address for class C. Okay. Since it's /24, we can consider this 255 as the broadcast address. Okay. Then the first address. Then the next address of the network address, which is 192.168.3.1 or 192.168.2.1 or 192.168.1.1. All these are considered as the first valid host address or usable host address. Okay. Why? Because the network address and the broadcast address can't be assigned for any end devices. Okay. Because for the network address, we are using the network address to represent a particular network or subnet. The broadcast address is used to send messages for all hosts in the network at a time. Okay. So at the same time, if you wanted to send all these hosts a message, you can send it via the broadcast address. If you ping the broadcast address later in a packet tracer simulation, you will get reply from all these hosts in the particular network. Okay. So the network address and broadcast address can't be assigned for the end devices. So in any network, if you find the total amount of IP addresses, you need to deduct 2 IPs in order to get the valid or usable host addresses for your end devices. For example, in this subnet, you might know from 0 to, which means 3.0 to 3.255, you will have 256 addresses. Okay. But you need to deduct 2 from that. One for the network address and one for the broadcast address. So after deducting, you will get 254 addresses, which you can apply it for the usable or valid host addresses. Okay. So note down the point. All these representations I am mentioning from 1.0 to 1.255 just because this is class C address /24. Okay. For /16, it won't be like this. It will change from the IP range from 0.0 to 255.255 would be the network and broadcast addresses in that scenario for /16. Okay. Scenario for /16. Okay. So which you will understand when we try to figure out the answers for the calculation. Okay. By now, just know these network address and broadcast address, first usable valid host and last usable valid host, and next networks network address. Likewise, these key terms must be understood before you approach the calculations. Okay. So if you know the broadcast address, you can simply deduct 1 to find the last usable or valid host address. And also, if you know the first network address and second network address, from the second network address, if you deduct 1, you can get the broadcast address. Okay. For example, if you have 3.0 and the second network you are having 4.0, so you can deduct 1. Or if you know what could be the previous address of this network, if it is ending with 0 means previously it should be 255. Okay. Once after the 255 only you will get 0, right? So for that, from 4.0 to find the previous address, you must know it would have been ended with 255 and the third octet should be reduced 1, right? So 3.255. So these are the minute things you need to know before you make any calculation. Okay. all the time we won't have around more than 250 hosts for a particular network, right? So for example, let's say if you have 3 floors in your company, all floors are having one switch. So for particular one floor, you are assigning 192.168.1.0 network. In that floor, you will have 0 to 255, which means you can have around 254 IP addresses or network devices. Okay. For the second floor, you are applying 192.168.2.0. There also you can have up to 254 network devices. In the third floor, again the same, 254 network devices. So as a result, let's say in your first floor you are having around 200 network devices, but in the second floor you are having only 80 network devices. So what happens here in this network assignment? From the first floor, if for the 200 network host requirement or network device requirement, if you assign this net, so for the first floor, if you assign around 254 IP addresses network for a 200 network or network device requirement, it's okay. Okay. Let's say for the second floor, for only around 80 host requirements are there. Okay. But if you assign this 2.0/24 network, what happens? All the IP addresses except that 80 addresses are going to be wasted, right? You can't use it for the third floor. Let's say for the third floor, if you have only around 10 to 20 network devices, for that you don't need to assign this much of big network, right? So if you assign that, you are wasting around more than 200 IP addresses for just 20 IP addresses. Okay. So for these kind of issues, we are using the subnets. We are subdividing these networks into certain portions. For example, let's say here for the 80 hosts, if I divide it into two halves, for example, from 2.0 to 2.128. So for example, 128 addresses from 0 to 127, I can assign for a network. Then the remaining, I can use it for the third floor. Okay. Likewise, I can save my entire 192.168.3.0 for a different network requirement, or later I can use it. Okay. For example, so just understand, subnetting is like kind of grouping the IP addresses into certain levels, okay, as per your network requirement, so that you can save the IP addresses. From 192.168.3.0 to 3.255 means you can simply group it from 0 to 64, from 64 to another 228. So you can group the 192.168.3.0 to 192.168.3.255 by dividing it into 4 groups. For example, 0 to 63. Then another group for 64 to 127. Then another group for 128 to 191. Then from 192 to 255. Okay. So all these are considered as the block size, which means block size comes under 4, 8, 16, 32, 64 or 128. On each octet, you can have around 4 or 8 or 16 IP addresses in each group, or 32 or 64 or 128. These are fixed values. You can consider it as a multiplier. Okay. In our calculation, I will mention a term called multiplier, which is what I mentioned. By the multiplier only, it will increase. Okay. The size of the multiplier represents your IP addresses in particular subnet. All these groups are considered as a subnet. Okay. Subnetwork. Okay. Earlier for the 3.0, you will consider as a 3-dot network, right? Now the 3.0 is going to be subnetted. Okay. So subnetworks. So as per our network IP requirement, you can subnet the second octet, third octet as shown in the picture. To understand this even better, you can have a look at this IP and so to understand this concept even better, you can have a look at this picture. Okay. So in a environment, so in a company environment, let's say this is branch 1 and branch 2, which is having first floor and second floor, and other branch also you are having 2 floors. For first floor, let's consider it as a local area network, which means coming under same network, the requirement is 250 hosts. Okay, which means 250 network devices are there in this particular LAN. Okay. Likewise, for the second floor, again 100 hosts are there in the second LAN. You can consider it as 100 network devices, PCs, laptops, printers, whatever. Likewise, on the branch 2 also, the host requirements are changing. Okay, 50 hosts or 10 hosts, likewise that. Okay, for these purposes, we will use the variable length subnet mask. Okay. Earlier when I explained, on each subnet the number of hosts is not going to change. On each subnet 64 is the host size, mean on each subnet it will have 64 IP addresses. But now I am going to change into certain subnets I need like 250 hosts, in another subnet I need only 100 hosts. Likewise I can modify. Okay, I can't exactly modify or exactly I can't allocate 250 hosts on a particular subnet, but I can go for a closer value for that. 250 hosts means I can go for 256 IPs. So I can minimize the wastage of IP addresses. If I need 100 hosts, I can go for 128 IPs. So only the 28 IPs are extra, which I can use it for a later purpose. If I go for 256 IPs on just 100 IP requirement, which means I am wasting too much of IP addresses, or I'm just keeping too much of IP addresses without usage. I can use the remaining IP addresses for the third LAN requirement here in the 50. Okay. So likewise, we are going to do the subnets. So to understand this concept even better, if you have 192.168.0.0/16, okay, let's say it's a class B IP address, so I can go from 0.0 to 255.255 in the last 2 octets. For that much of hosts I can have. Okay, so let's say I don't need that much of large amount of end devices here in a particular network. For example, here let's say for this particular flow, I can connect only around 254 IPs. If it is enough for me, I don't need to go for this /16, right? I can simply go for /24. So 192.168.0 dot is going to be a fixed value. And the remaining 0, 4th octet, is going to change from 0 to 255. Okay, so from 192.168.0.1 to 192.168.0.254, I can allocate for these PCs. Okay, the remaining next subnet is going to be 192.168.1.0/24, right, which is also going to have around 254 IP addresses. But here in this requirement, if I don't need that much of 254 IPs, then I can subdivide it, which means I am subnetting it. So here you can see first subnet, the IP addresses are going to be around 128. Okay, so from 192.168.1.1 to 192.168.1.127, I can allocate for the other group, other subnet. Okay, if you don't understand this concept, don't worry about that. By doing the calculation, you will understand it better. Okay, now I'm just giving the introduction of the scenario, what is happening. Okay, so if you understand this scenario, then when doing the calculations, it will be easier for you. You can recall it. Okay, for this scenario only I have done these calculations like that. Okay, this is just an introduction. Next, for the 192.168.128/25, I can allocate for the third host requirement. Okay, don't confuse with the /24, 25, 26 and why it's changing like that. Everything I will explain in a later session, so don't just confuse it by now. So for small host requirements, for few subnet requirements, you can use it and subnet again and again, and you can allocate it. Okay, so this is what happening in subnetting. Okay, so here simply understand, from one subnet to other subnet you can't communicate. Okay, from 192.168.1.128 network you can't communicate with 192.168.1.0 network on /25 or 192.168.0.0 network here /20. You can't ping from this species to this species. Okay, you need a router in order to do that. Okay, so now you can understand the question types. For example, they will give you number of host requirement on particular subnet. Okay, so equal for each and every subnet, if they need a particular number of hosts, then they will tell that, and you need to do the network calculations and figure out the network addresses, broadcast addresses, valid host addresses and all. Okay, in another scenario they will tell you how many subnets they need. They won't specify on each subnet how many hosts they need. They will just tell you this much of subnets they need, this much of networks they need. Okay, separate networks they are required. So that they will tell you, and they will ask you to find the network addresses and suitable addressing format. Okay, in a third scenario they can ask you to figure out on which subnet the particular IP is from. If you have several subnets, they will give you a random IP address and subnet mask, which means /22, /25, /18 like that, and they will give you the IP address and the slash notation, and then they will ask you from which subnet this particular IP address is from. That also we need to figure out. And in the fourth scenario, they might ask you for varying number of hosts per subnet, which means, as we already discussed, in a company environment as shown here, for each and every subnet here you are going to have different number of host requirements, right? For the first LAN you are getting 250 hosts, for second LAN you are getting 100 hosts, third LAN you are getting 50 hosts, and fourth you are getting 10 hosts. And also if it is branch 1 to branch 2, for the WAN connection also you need 2 IP addresses, 2 usable IP addresses. So for this also you need a particular subnet with 2 host requirements. Okay, so that also you need to know. This is the question for varying number of host requirements on each subnet. Okay, okay, then at last you will have the route summarization. For the first 4 types of questions you must do certain calculations and you need to know certain logics, but for route summarization it's very easier. You just have to write the answers in a binary format and find the common digits on that. It's little easy, so you don't need to bother about the route summarization. Just focus on the first 4 types of questions. Okay, so if you remember this right, you can answer all your IP calculations. Okay, so as I asked, this bit borrowing table you need to remember. If 1 bit borrowed, you will fill the subnet mask as 128 on the particular octet. 2 bit borrowed means 192, 3 bit 224, 4 bit 240, 5 bits 248, 6 252, likewise it goes. Okay, and for /8, 16 and 24 you will have it like 255.0.0.0 and further. Okay, and also you need to know the 2's power of value, which means 2 to the power of 1 is 2, 2 to the power of 2 is 4, likewise up to 2 to the power of 10 you need to remember. Okay, because most of the scenarios they ask less than 1024 host requirement. Okay, because if you connect around more than 1024 devices on a particular LAN or particular VLAN, then the speed might reduce a bit. Okay, so for that purpose you can simply remember up to 2 to the power of 10. Okay, to easily answer the IP calculations, I'm using this table. Okay, so if I approach via this step by step, then I can easily reach the networks. Okay, for example, if they ask you to create subnets or to find the subnets, you are using two jargons, 2 to the power n or h, okay, for the first calculation. Then the next step is subnet mask, which I represent as mask. Then the next step is multiplier. Then I will go for the networks. Okay, so simply remember NH, mask, multiplier, network. This is the jargon you need to remember for finding the subnets, for writing the networks, everything. Okay, NH, mask, multiplier, networks. I will explain how to process with this in the next section. Now just remember this. Okay, 2 to the power n or 2 to the power h, which means NH, then subnet mask, then multiplier, which means number of IP addresses in a particular subnet, multiplier, then networks, the first subnet, second subnet, third subnet, networks. Okay, and we can write the broadcast and everything later. Once we found the networks, you can write it. Okay, in another scenarios, they ask you like to find a particular IP addresses from which subnet. Okay, they'll give you an IP address and they are asking you to find this IP address is from which subnet. In that scenario, you will simply modify this first jargon into a bit different way. For example, NH mask multiplier. In between, you will add the division and multiplication and then the networks. Okay, so I will explain this as well when doing the calculations. So first of all, when they give you an IP address, you need to find out. They will tell you how many hosts they need. If they are telling you about the host requirement, the first type of question, you are going for the 2 to the power h. Okay, the 2 to the power h value must be greater than or equal to the value they specify for the IP addresses plus 2. Okay, with the IP address requirements they specify. For example, let's say if they are asking you around 22 hosts they need per subnet, then you need to apply 2 to the power of h greater than equal to 22 plus 2, which means 24. Why? The plus 2 occurs because for the network address and the broadcast address. The broadcast address. So they will specify the host requirement only. For example, if they say 80 hosts they need, then in your subnet you need a network address and a broadcast address for that 80 IP addresses. Okay, so altogether you must need 82 IP addresses in the particular subnet. So for that reason we are writing 2 to the power h greater than equal to 82. By doing this, you will find the host bit value. If you find the host bit value, you will move on to write the subnet mask. Okay, so if you know the host bits, you can simply deduct it from 32. So 32 minus the host bit will give you the subnet mask. Okay, which means it will give you the network bits. So from the network bits, you can write the subnet mask, right, as shown here. And then after writing the subnet mask, if you deduct the subnet mask last change occurred octet from the 256, then you can get the multiplier. Okay, all this I will show you by doing the calculations. Now I'm just introducing you the stuff we are going to deal with in the next session. Okay, after finding the multiplier, you can simply write the first 3 networks. Okay, we can write any network. Here for example, we'll write the first 3 networks, and from the second network, if you deduct one IP address, you will get the broadcast address of the first network, first subnet. Okay, After finding the network address and broadcast address, you can simply write the valid host ranges. Okay. And in a later session, I will explain the division and multiplication. So here nothing, we just find the multiplier. We will take the IP address and we will divide that particular IP address digit by the multiplier. After dividing the multiplier, you can simply multiply the answer in a full number without decimal values. Okay. So then after multiplication, the answer will give you the network address of that particular IP address. If the IP address is inside any subnet and they are asking you to find the subnet value, you can simply find the multiplier and then you will divide the IP number and then again you will multiply it and you can find the networks. Okay. So we'll see the 5 types of questions next. So next we'll have a look at specifying the fixed host requirements and asking us to find the subnet gateway. So here they will tell you how many hosts they need on a subnet. Remember here in each subnet the host numbers are going to be fixed. So in any number of subnets you will get equal amount of hosts. For example, in your first subnet, if you have 64 hosts, in the second subnet and third subnet, still you will have 64 hosts only. Okay. So they will tell you they require around 60 hosts in a subnet. Then you have to calculate the amount and find the subnets. Okay. So here we are going to use the jargon again. MASK multiplier networks. Okay. So for example, let's say 192.168.0.0/16. They are giving you this IP address and they are asking us to calculate for 250 hosts per subnet. Okay. So we need to figure out certain network addresses of the first, second and third subnets. Okay. So here first step is 2 to the power nh. If the question is asking about host, then you are going for the 2 to the power h. If they specify about number of subnets, in a few moments we'll do that question as well. If they specify about number of subnets, sub-networks, right? So in that case, you will use the equation 2 to the power n. Okay. So now they are specifying the host, so you are going for 2 to the power h. 2 to the power h greater than equal to 250. So 250 hosts plus the network address and the broadcast address. So that you need to add 2 with that. Okay. Remember, for this host requirement, you are adding 2. When we do the subnet requirement, in that case, you don't need to add 2. Okay. In the next question, we will deal with the subnet requirement. There you can specify the number they give itself. You don't need to add additional 2 here. Okay. Additional 2 here. Okay. So these are the differences between both type of questions. Okay. So here for 2 to the power h greater than equal to 252, which means you can go for 2 to the power 8 gives you 256, right? So that is the closest value possible because you can't go less than 252. Okay. It should be greater than or equal to 252. So the best choice is 2 to the power 8. You can't go for 2 to the power 9 because at that time you will get around 512. Okay, 512 is too much higher than the required host value. Okay, if they are requiring 250 means go for the closest value but greater than or equal to that value. Okay, so 256. So now we have found h is equal to 8, right? Which means your number of host bits are 8. In this IP address, altogether you will have 32 bits. So here for this 250 host requirement, you only need 8 bits. Okay. So for the host portion, if you need 8 bits, what about the network portion? Okay. So network portion you can simply calculate by deducting it from 32. So 32 minus 8 is going to give you 24. So your network portion is having 24 bits, which means your slash number is CIDR is going to be 24, right? So if CIDR is 24, you can simply write the subnet mask. So first 3 octets, 8, 16, 24. All these are going to be network portion, so filled with ones. So you can write it as 255.255.255.0, right? So next, after writing the mask, you need to go for the multiplier. Okay. To find the multiplier, you need to find from right side to left side, which is the last change occurred octet. So here the last changed octet is 255, right? The third octet. So what are you going to do is, you are going to deduct this last change of occurred octet from 256. Okay. So if it is happening in the second octet, you will deduct it from the 256. If the last change occurred in the fourth octet, you can deduct the value from 256. If it is happening on the second octet, again you can deduct the value from the 256. Okay. So 256 minus the 255 equals 1. Okay. So the multiplier is going to be 1 on the third octet. So here in the third octet, the value is 192.168.0. 0 is in the third octet. So in that third octet, the value is going to increase by 1, okay, for each subnet. So 192.168.0 is one subnet, 192.168.1 is another subnet, 192.168.2 is another subnet, 192.168.3 is another subnet. Okay, likewise it's going to happen. So after finding the multiplier, you can start writing your networks. You can see it here. So the multiplier means the increment on the particular octet. So here third octet, it should increase by 1. So 192.168.0.0/24 now is the first subnet. Okay, why? We know now the network portion value is /24, so you can write it as /24. Okay, not 16. 16 is the IP they gave. After finding the subnet details, we change it into 24. So what about finding the next network address? Next subnet is 192.168.1.0/24. Why? The multiplier is 1. What about the third subnet? 192.168.2.0/24 and 3.0/24. Likewise it goes. Okay, it goes. Okay, so you can figure out, if you take only the 192.168.0.0/24 from 192.168.0.0 to 192.168.0.255, you will have in the same network. Okay, so the network address is 192.168.0.0/24. The broadcast address is the last address, which is 192.168.0.255/24. The first usable or valid host address is 192.168.0.1/24. The last usable host address is 192.168.0.254/24. Okay, which is less than the broadcast address. Okay, and the next network address is 192.168.1.0/24. Okay, so likewise the IP addresses flow. You need to practice IP calculations very frequently because this can leave out of hand very quickly. Okay, again and again repeatedly try these calculations and have some notes, then only it will be easier for you to understand. Okay, so now we know how to find the subnets or networks when they ask about the number of hosts. Okay, so next I will explain some of the questions. so that you can try it out. So here you can see 192.168.0.0/16. Okay, for this network, in one question you need to answer for the 505 hosts per subnet. In a subnet, they are requiring 505 hosts. In another scenario, same IP address, if they require 45 hosts per subnet, then you need to answer for that. Then 63 hosts per subnet, 127, then 255 and 254. Okay, so for each and every questions here, you can see there's a hint, which means, as I told, if they specify the host per subnet, definitely you are going for the 2 to the power h greater than equal to, the value must include +2, right, for the network address and the host address. It means here if they specify 505, you need to add 2 and 507 should be your calculation. Okay, 2 to the power h greater than equal to 507. For 45 hosts, you are going to specify 2 to the power h greater than equal to 47. Likewise for 63, you can see the difference if you apply 63 and find the answer, and if you apply 65 by adding 2, find the answer for that as well, and then compare, both answers would be different, right? So this is the reason why I specify the particular number of hosts, 63 and 127, which means if you add only for the 127, you will be going for 2 to the power h greater than equal to 127, means your answer will be wrong, because with 127 the h is equal to 7. Okay, but if you added 2, 127 plus 2 means 129, so that 2 to the power h greater than equal to 129 means here you will get h equal to 8, right, which is going to give you 256 IPs. Okay, so likewise you can try other questions as well, and 172.22.0.0/28. okay, and 12 hosts per subnet. For the next one, 172.22.0.48/28, okay, which is a subnet of the previous one specified here. Okay, I'm just explaining you some of the important points here, okay, so that you will have a broad idea about the exact questions. So in this question they are asking 8 hosts per subnet. Okay, so here your first network is going to be 172.22.0.48 only. Okay, it's going to start with that 48, and after the calculation the slash number might change and all that. When you perform the calculations you will understand. Okay, and then for the last one, 10.10.13.128/25. okay, 6 hosts per subnet. Okay, in each and every scenario, mainly you can go up to /30. Why? It's /30 because /30 means your network bits are 30, the remaining 2 bits, which means 2 to the power 2 equal 4 IP addresses. 4 IP addresses are minimum requirement for a subnet. Why? One for the network address and another one for the broadcast address. Okay, the remaining 2 addresses are going to be assigned for 2 PCs or 2 network devices. Why? The minimum network is considered, you need to connect 2 PCs at least, right, to make the communication among them. So this is the reason. So at least 4 IP addresses are needed for a subnet. Okay, minimum 4 IP addresses must be there in a subnet. Okay, so /30 is the maximum you can go up to. So this is one point. So when adding 2 to the power h equation, you need to add 2 here because it's hosts per subnet. This is another point. After finding the host bits, what are you going to do? You need to try the network bits. You can try it by 32 minus the host bits you found here, 2 to the power h, that h bits. Okay, then you will get an answer for the network bits. By finding the network bits, then you can do calculations of the subnet mask, nh mask multiplier networks, right? So nh we have done, then mask. Subnet mask we can find by the slash number, you can write it. Okay, and you can refer the bit borrowing table as well, as I told, 128, 192, 224, 240, then 248, 252, 254 and 255, right? So after that, multiplier, you can deduct the particular last octet change occurred value from right to left. Okay, so you need to deduct it from 256 and get the multiplier on that particular octet. Okay, let's say if it is happening in the second octet, the last change, then if you find the multiplier is going to increase on the second octet only. It's not going to increase from the last or third octet. Okay, that you need to remember. Then after finding the multiplier, simply you can write the networks or the subnets by increasing it by the multiplier. Okay, so these are the things you need to know. Then we'll move on for the next type of questions. So now, if the question specifies the number of subnets required and they are asking you to find the subnet details. Okay, earlier they specified the number of hosts per subnet. Now they are specifying how many subnets they need, how many networks they need. No matter how many hosts are in each subnet, that they didn't mind. They just wanted you to create certain amount of subnets. Okay, that is the requirement here. So here in this scenario, we don't need to add 2 for each, like 2 to the power n. You don't need to add 2 here. Why? Because your each and every subnet is going to have a network address and a broadcast address inside. Okay, that you don't need to specifically add. It's already included inside the subnet, so you don't need to specify it. You just simply use the number of subnets required in the 2 to the power n. Okay, so here you can see 192.168.0.0/16. 40 subnets are required, which means we need to create 40 subnets. Okay, just imagine we are assigning 40 networks to 40 switches. Okay, this is not the real scenario. I'm saying this because if you think like that, you can reach the answer easily. Okay, so 40 subnets are required. I am using my jargon 2 to the power nh mask multiplier networks. Okay, so since it's subnet specified, I can go for the network. So 2 to the power n. 2 to the power n greater than equal to the same number they specify. Okay, 40 means you specify the 40 here. You don't need to add 2 here. Okay, 2 here. Okay, if they specify host per subnet, then you will add 2 with the 40. Now they are specifying only the subnets, so just add 40. Okay, so then 2 to the power n greater than equal to 40 gives you 2 to the power 6. Okay, so n is equal to 6 means you need 6 more network bits. Okay, earlier what we did, if you find the 2 to the power h answer, you will deduct it from the 32 and you will consider the remaining all are network bits. Now it's not the scenario. You need new 6 bits from the host side into the network side now, which means you need 6 bits for the network side additionally. For example, let's say here already /16 is there, right? Which means 16 bits are already in network side now. Okay, now for the 40 subnets, you need additional 6 bits for the network side. So what you need to do is you need to add the 16 with the 6. Okay, so which gives you the answer 16 plus 6 gives you 22. Okay, so now the network portion bits are 22, which means /22 here. Instead of the 16, it's going to be /22. So if you find /22, you can find the subnet mask as well. Okay. So 22 is greater than 16. So simply you will know first two octets are going to be full, which means 255.255. Why is greater than 16, right? Then the remaining, if it is 24, the third one would be also full, but it's not filled fully. So now 22 minus 16 is going to give you 6 bits. Okay, so 6 bits more increase. So you can simply figure it out. You have 6 bits more for the network portion, right? Plus 16. So 16 means first two octets are going to be completed, which means 255.255. The third octet is not yet completed. It is having only 6 bits for the network side. So 4 bit means you can have 240 here. 5 bits mean you can have 248 here. 6 bit mean 252 here. Okay. You can refer our bit borrowing table earlier. I showed it. You can see that now. And then for the fourth octet, there is no network bit, so you can fill it with 0. Okay. So now you know the subnet mask 255.255.252.0. Okay. Then the third step, multiply. NH mask multiply, right? For the multiplier, what are you going to do? From right to left for the subnet mask. The last change occurred in the 252. So you need to deduct the 252 from 256. So if you deduct 252 from the 256, you will get the answer as 4, which is the multiplier on the third octet. So the third octet is going to be increased by 4 on each subnet. Okay. So you can find the networks by writing 192.168.0.0. Now the subnet mask is /22. So you can write /22 here. This is the first network. For the second network, in the third octet, it should increase by 4. So 0 plus 4 is 4.0. You can write /22 again. Okay. So likewise, you can write continuously 192.168.0.0/22, then 192.168.4.0/22, then again 192.168.8.0/22, then 192.168.12.0/22. Likewise, you can go. Okay. So after writing the first network, again we try to write the network address, valid host, and broadcast. Okay. So for the network address, you can try 192.168.0.0/22. First valid host is the next address of the network address, right? So 192.168.0.1. Okay. Why? You know the IP flow, right? It increases from 0 to 255 one by one. Okay. So then the second network is 192.168.4.0/22. 4.0/22. So you need to reduce the 1 from second network address in order to get the broadcast address of the first subnet. So if you reduce 192.168.4.0 means 0 comes after the 255, right? So you can specify 255 and you need to deduct 1 from the third octet, which means 4 minus 1 is 3. So you will get 192.168.3.255/22. If you have any doubts, you can check our IP flow explanations, so you will understand this better. After finding the broadcast address, you can again deduct 1 from the last octet in order to get the last valid host. Okay. So 192.168.3.254 would be the last valid host. And now you might know that anyways network address and broadcast addresses can't be assigned for the network devices. You can go from 192.168.0.1 to 192.168.3.254. Okay, for the network devices. So here you must know a simple point is this is going to be like 0.1 to 0.255 and then 1.0 1.255 then 2.0 2.255. Likewise it goes. Okay, a huge amount of IP addresses are inside in between these first valid host and last valid host. I just showed a cursor here, but there's a huge amount of network IPs in between these two. Okay, if you want, you can try writing a bit and get some clarifications. Okay, if you have any doubts, you can ask me. So here I have included some of the questions for you to practice, like 40 subnets or 65 subnets, and you can see 192.168.0.0 from 40, 65, 128, 127, 255, 254, and for a different IP address 172.22.0.0/28, we need 2 subnets or 4 subnets. Likewise, you need to do the calculations. Okay, so you can simply figure it out. And there's another point in real life. If you didn't understand this part, it's okay for this one. I'll just explain a bit, which means, let's say, as I told earlier, for any subnet, the minimum IP requirement is 4, right? 4 IPs are needed for one subnet. In your one octet, 256 IP addresses are there, right? So if you divide the 256 by 4, you will get 64 subnets. Okay, so which means within 256 IP addresses, you can make 64 subnets. Okay, so let's say if somebody specifies you a large amount of IP addresses and they are asking whether you can create the subnets for this within a specified network. So first of all, you need to find within the particular network how many IP addresses are available. Okay, like here, as I told, 256 IPs mean you can find in this network how many IPs are available. After finding the number of IPs, you can divide it by the 256 and figure it out that much of subnets are possible within the network or not. Okay, so you can simply find the subnet, number of subnets. So for all of these questions, just try to write the first 3 subnetworks and broadcast addresses, valid host and last valid host. Okay, and this part, if you didn't understand, it's okay, just this is an additional point. Okay, next we'll move on further, asking us to find the subnets for varying amount of host requirement. Okay, so up to now what they specified is a particular amount of host range. Maximum amount of host in a subnet is not going to change that. Okay, the host number will be equivalent on each and every subnet. Now this scenario is going to change. For each network or LAN, local area network, definitely the host requirement might change. Some of the networks might require more host and some might require less. So what we are going to do is, we are going to do the varying amount of hosts for the subnets. For example, just consider a LAN like this. You are having branch 1 and branch 2, and inside you will have 2 floors, LAN 1 and LAN 2. Likewise, in branch 2 also you are having 2 floors. So for the first LAN, you will have around 250 hosts, for consideration. For the second LAN, they are asking 100 hosts. In the branch 2, for the first LAN, there is 50 hosts, and the next one 10 hosts. Okay, so here you can find 1, 2, 3 and 4 subnets are allocated for the LANs. And then another point is, from branch 1 to branch 2, the serial cable is attached. This is considered as the WAN, wide area network. For this also you need to allocate a particular subnet. So altogether you need 5 subnets. So here you need only 2 IP addresses, because one for the incoming of this branch and the other one for the incoming of the other branch. Okay, so altogether we are going to create 5 subnets. First of all, when doing this calculation, you need to move from descending order, which means from the highest value to the lowest. Okay, so 250, 100, then 50, then 10, then 2 for the WAN. Okay, So one by one again we'll subnet this particular network 192.168.0.0/16. So here our calculation is mainly focused on hosts per subnet. Okay, I informed that we need 5 subnets needed, but the calculations are mainly focusing the number of hosts on each subnet. Okay, so what you need to do is 2 to the power h greater than or equal to the particular number plus 2. Okay, this is the idea. So here you can see 192.168.0.0/16, 250 hosts per subnet. So I am just continuing the same process, so I believe I don't need to explain this again and again. 2 to the power h greater than or equal to 252. So here h equals 8, then 32 minus 8 is going to be my network bits. So I can specify the subnet mask as 255.255.255.0, and then again after writing the subnet mask I can find this is the last change occurred position, which is the third octet 255. So I can deduct it from the 256. So 256 minus 255 is 1, which is the multiplier on third octet. Okay, so I can write the networks now 192.168.0.0/24. Then in the third octet it's going to increase by 1. So 192.168.1.0/24. Then 192.168.2.0/24. Then 192.168.3.0/24. Likewise. Okay. After that I can simply write the network address and broadcast address and other details like first valid, last valid as always. Okay. So 192.168.0.0 to 0.255 it goes. Why? It is a class C address. Up to /24 means the first 3 octets are not going to be changed. It's fixed. Okay. If it is /16, the first 2 octets would be fixed. Okay. If it is /8, the first octet would be fixed. The remaining will start increasing one by one. Okay. Now you know the next subnet is 192.168.1.0/24. Okay. So up to here the calculation is very simple and we have done it previously. Only change what is going to happen here is once after you found the first network, you are going to allocate the 192.168.0.0 for the 250 host. Okay, that is right. After that you have 192.168.1.0/24, which you are going to again subnet and find the 100 hosts per subnet requirement. The second requirement you are going to allocate this one 192.168.1.0. okay, which means we are going to subdivide this 192.168.1.0/24. Still we have additional 2 networks, which means 2.0, 3.0 and all are there, but I am not taking those. I am going to subnet this one first and allocate it for the 100 host requirement, and if I again needed to subnet, I will again do it for the same 1.0 network. Okay, 0 network. Okay, until I have enough IPs in this 1.0 network, I don't need to go for the 2.0 or 3.0. That is the idea here. Okay, so in this way I can save from the 192.168.2.0, 3.0, all I can save. I can use it later. Okay. So now in the next our requirement is going to be 192.168.1.0/24 to be again subnetted for the 100 hosts per subnet. Okay, you can see this. Now note down it's /24. Earlier it was /16. We subnetted for 250 hosts and we found it as 0.0/24, and now 192.168.1.0/24 for the 100 hosts per subnet requirement. So here what's happening is 2 to the power h greater than or equal to 102. So 100 plus 2 is 102. H equals 7. 2 to the power 7 is going to give you host bits are 7. Again the same calculation. So 32 minus 7 is 25 bits are going for the network portion, and you are writing the subnet mask as 255.255.255.128. Why? If it is 24, you are going to write 255.255.255, and 25 means one more bit on the 4th octet. If one bit borrowed, you need to write 128. Okay. Next, here you can find the last change occurred octet is the 4th octet, which means 128 in the 4th octet. You can deduct this 128 from 256 in order to get the multiplier. So here the multiplier is on 4th octet. 256 minus 128 is 128 on 4th octet. So you can write the networks by 192.168.1.0/25 now, okay, after the subnetting. So the next network is going to be increased by 128 in the 4th octet. So which is 192.168.1.128/25 again, okay. So which represents 25 here, you can note down. Then still we have our 192.168.2.0 and 3.0/24, which we saved earlier. I just bring it here to note down, okay. Here you can use this 192.168.1.0/24 has been subnetted into 192.168.1.0/25 and 1.128/25. Two networks we found. So we'll take the first network for the 100 hosts. You can find it's having around 128 IPs, right? Multiplier 128 means you are going to have 128 IPs. Multiplier 128 means you are going to have 128 IPs on this particular subnet. So I can write the first network address 192.168.1.0/25 and 1.1/25 is the first valid host. Then the last broadcast address can be found by 192.168.1.128 minus 1, which is going to give me 192.168.1.127/25. This is my broadcast address. Then if I deduct again 1 from this broadcast address, I will find the last valid host, which is 192.168.1.126/25. And next subnet I can get 192.168.1.128/25. Okay. So likewise, now I have subdivided the 1.0/25 network and got 100 hosts in this particular subnet. Okay. So what is my next purpose? I need 50 hosts per subnet for the other branch LAN. Okay. For that 50 hosts, I can simply find, rather than going for the 192.168.2.0, I can again subnet this 192.168.1.128/25, right? Why? Because it is also having around 128 addresses, right? So I can again subnet this one. So let's do the calculation for that in the next slide. So you can see 192.168.1.128/25 with 50 hosts per subnet. So here I can again do the calculation. 2 to the power h greater than equal to 52 and h equals 6. I'm just rushing this out because we have done all these calculations earlier in a slow pace, right? Now you can recall it, or else you can view that and again do some practice and view this one. Okay. So h equals 6. If you find 6 bits are for host bits, you can deduct it from 32. So 32 minus 6 equals 26, which gives you your network bits. Okay. So if it is 26 on network bits, you can write the subnet mask as 255.255.255.192. You know the reason? 24 means 3 times 255. Another 2 bit borrowed means 192. Okay. Refer the bit borrowing table. Then go for the multiplier by deducting this 192 from the 256. So 256 minus 192 gives you 64, which is the multiplier on 4th octet. So again, you know the networks 192.168.1.128/26 you need to add around 64 again with this 128 for the next network. So 192.168.1.192/26. Still you need to remember that 192.168.2.0/24 and 3.0/24 are still available. We are not using it yet. Okay. So this is the purpose. We have enough IP addresses and we are subnetting the subnets again. So we can save these 2.0 or 3.0 again later for any other purposes. We can use this. Okay. So this is how we need to save IP addresses. Then for the 50 hosts per subnet, I am going to allocate this first network 192.168.1.128/26, which is the network address, and the second network of the subnet is 192.168.1.192/26. So to find the broadcast address, 1 minus 192 is going to give me 191. Okay. So 192.168.1.191 would be my broadcast address, and if I found the network and broadcast, you know how to find the first and last valid host, right? So I am not explaining it again. Then again what? The next requirement is 10 hosts per subnet. You know the diagram, right? I showed the lab, and in that the next one is 10 hosts per subnet. Again here I have found this 192.168.1.128/26, and I am going to allocate this network into my 50 hosts per subnet. Again what I am going to do is I am going to take this 192.168.1.192/26 network address, which I am going to use for my next requirement, 10 hosts per subnet. Okay. So here you can see 192.168.1.192/26 for 10 hosts per subnet. Again I need to add 10 plus 2 for the network and broadcast, and I am doing the calculation, repeating the same process. H equal 4, so n equal 32 minus 4 equals 28. So subnet mask 255.255.255.240 is the 4-bit requirement. Okay, if you borrow 4 bits, you are going to have 240 here. After that, multiplier 256 minus 240 gives you 16, which is the multiplier. Then you can write the networks. 192.168.1.192/28, add 16, 192.168.1.208/28, then add 16, 192.168.1.224/28, then 192.168.1.240/28. Still you can find 192.168.2.0 and 3.0/24 are still available without use. Okay, we are saving it. Next, you can write the 1.192 networks, valid host, broadcast addresses, next subnet IP address on the network. Okay. After that, again you can find the 192.168.1.208/28 subnet. You take this subnet and again do the same calculations for 2 hosts per subnet, which means for the WAN link. Okay, wide area network, in between 2 branches you need 2 IP addresses, right? For that I am going to use this 208 network. Okay. So you can see 192.168.1.208/28, 2 hosts per subnet. So I can do the same calculations. H equal 2 means n equal 30 and 252 is the subnet mask. From that you can find the multiplier, which is going to give me 256 minus 252 is 4 in the 4th octet. So again I can write the networks, right? I am not repeating it again and again. You can simply understand this, right? So likewise I can write the 208 network for my 2 hosts per subnet requirement. Okay, and after that I have enough networks again. If I need anything, I can use these 192.168.1.212 or 216 or 220. All these are subnets. But since I don't have any requirement for this, I can just simply keep it for later usage. And still now you can remember 192.168.2.0/24 and 3.0/24 are completely saved. Okay, which means a complete network with 255 addresses in each network class C1. Around more than 250 addresses are there, right? Still we didn't allocate it because we saved it. That is our purpose and we got it, right? Next, by specifying an IP address, they will ask you to find out from which particular subnet this IP address is from. Which means, for example, let's say in the previous slide, you are having several subnets, right? Let's say if you need only 4 IP addresses in a subnet, in that case, you will have many subnetworks like this 208, 212, 216. Likewise, you will have many subnets. And for instance, they might specify a particular IP address. Let's say 192.168.1.118 or 1.218. Okay, let me go for that. 192.168.1.218. They will ask you from which subnet this IP address is from. So 192.168.1.218/28 is from this particular subnet, right? 192.168.1.216/28. Okay, so you need to find this one. So in order to find that, there is another calculation. You are going for 2 to the power nh mask multiplier, then division, multiplication, then networks. Okay, in between your multiplier and networks, you are adding 2 things, which is division and multiplication. Okay, I will explain it. So in this calculation, they are specifying 192.168.1.235/28 from which subnet. Okay, so in this calculation, they are asking you 192.168.1.235/28. So they wanted this particular IP address, the subnet network address. So you need to find from which subnet this IP address is from. Okay, so to do that, you just have to find the 2 to the power nh mask multiplier, division, multiplication, and networks. Okay, simply before I do the calculation part, I just explain this one. So you will have the networks like 192.168.1.192/28, 192.168.1.208/28, and 192.168.1.224/28 and 240/28. Okay, consider all these are different networks or subnet. Here the 1.235 IP is from this particular network, right? 192.168.1.224/28. You can see it here. It's shown, right? So after our calculation, the answer should bring us our 192.168.1.224/28. Okay, I'm just explaining the answer here so that after doing the calculation, you can confirm we got this answer. Okay, so this is what our requirement. So let's now move on for the calculation part. They are asking you to find particular IP address subnet, right? So initially you need to start from the /28 subnet mask here. Okay, subnet mask here. Okay, so /28 means you can figure out 24 plus 4, right? Which means first 3 octets are going to be completed with 255. So 255.255.255. And plus 4 you can write .240. Okay, so altogether 255.255.255.240. 4 bits borrowed from 4th octet. Okay, after finding the subnet mask, you can move on for the multiplier portion. So in the multiplier, you can find out 256 minus 240 in the 4th octet, because last change is in the 240. So you can deduct it from the 256 and find the multiplier here. So multiplier equals 16. So next you can find the particular IP address 235 on the 4th octet, you are having the IP value, right, 235. You need to divide this IP by the multiplier 16. Okay, so 235 divided by 16 is going to give you 14.68. Now after the division you need to perform a multiplication. Here you don't need to use the decimal value, only the 14 you can use, okay, without the decimal value. In full numbers just use it. So 16 times the answer 14, which gives you 224. Okay, so this 224 is going to be your digit on the 4th octet. So now we found the network or subnet address, right? 192.168.1.224/28 is the network address of this particular 235 IP address. Okay, so if you are having any doubts, just simply understand you need to find the mask multiplier. Okay, after finding the multiplier, simply divide and multiply the particular IP. First divide it, then multiply it, then get the answer. That's all. So here you can see 16 is multiplier, therefore 224 divided by 16 gives you 240. Therefore 240 can bring you the next subnet. These things you already knew, right? Once after, if you found the multiplier, you can simply add the 16 with this network address and find the next subnet. So to find the broadcast address, what you need to do? Again, you can deduct 1 from this 240. Why? This is the next subnet. Just deduct 1 from this and you will get 239 would be your broadcast IP. So 192.168.1.239/28 is the broadcast IP. Okay. Again, you can try these calculations like 135, 63. Likewise, the IP addresses inside the subnets have been given, right? So the network address and broadcast address of the subnets are required to be found. Okay, so you can try this out. And then in another way, if you wanted to do the same calculation, if you wanted to follow any tricky method, which means you can find this AND table. Okay, which means if all bits are 1, if all the values are 1, the answer would be 1, otherwise the answer is going to be zeros. Okay, so 1 times, think like it's a times table. 1 times 1 is 1, then for 1 times 0 or 0 times 0 or 0 times 1, everything is going to give you 0. Okay, just simply remember, if all are 1s in AND gate, the answer would be 1, otherwise for any other combination, answer is going to be 0. So here you can see 192.168.100.164 is going to be written in binary like this. Okay, and the subnet mask also /25 means again you can write this subnet mask and convert it into binary. Okay, after that do the AND operation, which means 1 and 1 means 1, 1 and 1 1, for 0 and 1 0. Likewise, you can perform the AND operation, and after the AND operation you can convert this again into decimal. Okay, and my recommendation is don't try this at the exam hall. Okay, so while converting, and they are going to give you a small whiteboard in the exam hall with a marker. Okay, so in that case, if you try to write this stuff, it's going to be confused, or like it won't be clear enough for you to understand. I don't think you can write this entire 192.168.100.164 equals in binary format in the whiteboard they are going to give, because they are not going to give you a A4 sheet and a pen. It's going to be a whiteboard, which is a small one, and a marker. While writing in markers, I don't think you can do it efficiently, these calculations. Okay, so best way, you can go for the methods what I specified. Just think here for the explanation only, I have written all these theoretical stuff and the guidelines, when you wanted to find the answer, you don't need to write these processes one by one. You can do the calculations only. Okay. By doing this, after around 5 to 10 times of practice on these IP calculations, you can simply reach the answer within a minute. And also you don't need to write this much of explanation. You just have to focus on the calculation part, which you can try in the whiteboard. Okay. You don't need to bother about the issue with this kind of calculations. Okay. For this one, I don't think you can do it. So up to now, we have performed all the IP calculations which involve with so many logics and calculations. Okay. The last method on IP calculations is route summarization, which is really easy. You don't need to bother about memorizing anything for the route summarization. As I explained earlier, here you have seen, right? We are converting into binary and we are figuring out the AND operation and all. For route summarization, it's even simpler. You don't need to do anything. You just have to write the IP addresses into binary format and find the common bits. So route summarization looks like this. Okay. You can see here I have specified certain routers. By now, let's discuss regarding the colors. Okay. Here there's a green color router and red one and 3 blue color routers. So here, let's say for example, the blue router is having certain networks, which is 172.16.64.0/24, 65.0/24, 66.0/24 and 67.0/24. Okay. So let's say for this red color router, if there is a traffic coming for 172.16.66.0/24, without any route summarization, what the router does is, it will check upon the 4 networks, 64.0, likewise, it will check all 4 networks, and after that it will send the traffic to particular router here. Okay. Just imagine if there is a traffic coming from the green color router to the red one, it will initially check upon these 4 networks, these 4 networks and these 8 networks. Altogether around 16 networks. It's going to check where the destination is for the particular traffic. After that it will find, okay, if you are coming for the 66.0 network, you need to go for this particular router. Likewise, it will forward the traffic. But when comparing all these 16 networks while checking it, the router needs to spend a particular amount of time, right? For us, it's a small amount of time, but for the router, it is a considerable amount of performance time. Okay. So when you do the route summarization, you don't need to bother about these 4 networks. You will simply summarize these 4 networks, 64, 65, 66 and 67. What if you can simply summarize this all 4 networks into one? Then you can specify only one network for this particular blue color router, then another one network for these 4, then another one for these 8. So in that case, the red color router only has 3 networks to be checked, right? Networks to be checked, right? For this network summarization, for these network summarization, then the summarization for this networks. Okay. So in that case, only 3 networks it has to check. When there's a traffic enters this router, it has to check only 3 networks, and if it finds the correct network, it will forward it there. Okay. So this is the purpose we are using route summarization. In order to do the route summarization, your network must be in a continuous manner. For example, let's say 172.16.64.0/24 and 65.0/24, 66, 67. All should be in same continuous way. Okay. If the 172.16.66.0/24 is taking place in the third router or second router's networks, then you can do the route summarization for 172.16.64 to 67. What happens if you do the route summarization in that way? Whenever a network traffic comes for this 66.0 network, which is in the third router now, whenever the traffic comes, it won't send it for the third router. Why? You have summarized it by mistakenly for this first router 66.0. okay, so you need to figure out all the networks are in continuous manner. If not, if anything missing, which means like 172.16.65.0 is not yet used now, means you can just avoid it and you can summarize it, but in future you can add the 65.0 to any other routers. Okay, you need to definitely add it inside this summarization. Okay, that you have to take a look. So next we'll go for the calculations. So next we'll have a look at route summarization. So first of all, we need to know why we are using the route summarization. For example, let's say if all of these networks specified here has been given for the red color router, okay, which means around 16 networks are mentioned. So whenever a traffic comes from this green router to the red router, this router has to check upon all these 16 networks and specify and figure out where this exact traffic is destined, where it has to go. After finding that, it will direct the particular traffic to the particular router. The problem here is when all of these 16 networks being checked by this red color router, it has to spend some CPU processing for checking these all networks. Okay, so this might take a bit of time considerably when it compares for the configuration done by the route summarization. Okay, after the route summarization, what we do is we will summarize all these 4 networks into a single network. Okay, and we will specify it to the red color router. Likewise for the next router also, you will summarize all these 4 networks and specify it to the red color router. Then for the 8 networks here in the third router, again you will summarize it and specify it for the red color router. Okay, so now what happens is, as a result, this router now has to check only 3 networks in order to figure out which path the traffic should go. Okay, so once after it figures out, it can simply direct the traffic. Okay, in order to do the summarization, the networks must be in a continuous manner. For example, 172.16.64.0/24 means 65.0.60.70 all should be in continuous way. Okay, which I explained earlier also. So now let's see how we are going to summarize it. So here you can see 2 to the power 0, 1, 2, 3, 4, 5, 6, 7, which means altogether we have 8 bits. So the values are specified 1, 2, 4, 8 and 16, 32, 64, 128, which is 2 to the power 7. Okay. By changing these bit values into ones and zeros, you can specify any number in between 0 to 255, which also I explained earlier. So now what we are going to do is, we are going to write our network digits in decimal value. We are going to convert it into the binary value. For example, if you wanted 172, you can write it by 128 plus 32 plus 8 plus 4. So you can simply mention 1 in the exact position. So when you mention 1 in the exact position, you can figure it out. Altogether you can find 172. Okay. For the remaining positions, you can mention zeros. Next, for 16, you need to write 1 in the 16th column. The remaining you can make it as zeros. Okay. For 64 means you can write 1 in the exact 64th column. all other remaining you can mention as zeros. Here it's shown 1 because I have written for 65. Okay, so for 65 you can have a 64 plus 1. For 66 you can have 64 plus 2. Okay, if you need 67 you can go for 64 plus 3, which means here in the 2 and 1 should be ones. Okay, so likewise, by changing each and every number into zeros and ones, you can specify the particular desired number you need. Okay, so by doing this you will write all the digits into the binary format as shown in the picture. Okay, for 64.0, 5.0, 6.0, 7.0, everything you need to read. Everything you need to write in binary. Around the 32 bits, you need to figure out how many bits are common. So here you can see 10, 10, 11, 00, 00, 01, 00, 00, 01, 00, 0011. So among here up to the 00 shown here, which means 22 bits, you can make that constant. Why? It's in a fixed value, right? So you can consider all these 22 bits are common for all of these 4 networks. So what we can do is we can change the /24 into 22 when we do the route summarization. Okay, and also for the network you need to specify the least network in this comparison. So 64 is the least one, right? So 172.16.64.0/22 is going to be our route summarization for the first 4 networks here. Then for the other router, again you will write like this and you will figure out the common bits and you will mention it as /. Okay, and likewise for the other 8 networks, again do the same and figure out. Okay, so by doing this we can make all these 16 networks into 3 summarized networks. Okay, so here it has been summarized, and again for the 8 networks it has been summarized. Okay, so now you can simply figure out 8 bits are common, and again 8 bits, again 5 bits, so altogether 21 bits are common here among these 8 networks. So you can mention it as 172.16.72.0, which is the least one, /21 by it is common. Okay, so again it has been shown. All these 3 networks are specified for the second router in the red color one. Okay, so whenever a traffic comes from this green router to the red one, it will check upon these 3 networks only. Okay, it's not going to verify all these 16 networks now, it's just going to see only these 3 networks. Okay, so whenever a traffic comes for the 172.16.70.5 or something, in that case it will check, okay, the 172.16.68.0/22 is the summarized network for this particular traffic, so that it will forward it to this router. Okay, likewise if there is anything coming for the third network, it will forward it here. Okay, now what next is you need to again summarize these 3 networks. The process is same, you are going to write it in binary and figure out how many bits are common. Figure out how many bits are common. Okay, so now what you are going to do is you need to write this and find the summarization and specify that particular summarization into the green router. Okay, so whenever a traffic comes from outside for any of these networks, it will check upon only one network, which is the summarization I have already done. So 172.16.64.0/20. So whenever a traffic comes from outside, it will decide, okay, this particular traffic is destined for these networks, so it has to forward the traffic to this router. This green color router might have around 3 or 4 more routers attached. So he will check upon this and he will send only the traffic to this particular red color router. Okay. By doing the summarization, the CPU processing time, everything got saved. Okay. So that we can benefit it from the route summarization like this. So you can see how the 3 networks have been written for the final route summarization. It has been converted into binary and then again found the common bits. So then you can find the least network number and specify the common bits value. Okay. So you can refer the table for further clarifications. Okay. So finally we have finished our entire routing IP calculations. So now you can make sure you are ready with all the IP calculations for your exam as well as in your real environment. You can use this knowledge. Okay. So practice this frequently so that you can easily figure out the answers. Okay. By now it might be difficult, but if you practice few more times, it's really easy. Okay. For the CCNA exam, there are several questions repeatedly applying for the IP topic. Okay. So the same type of questions, and I didn't mention any question directly, but I have mentioned the values and you can practice this so that in your exam it would be helpful for you. Okay. And only one topic which I didn't include here is route table verification on IP. Okay. That we will do after we configure the routing and static routing, OSPF, everything and all. Then we will discuss about the route table and all. At that time, if I explain route calculations and routing table and subnet calculation, then it would be easier for you. But by now, the process of finding the subnets and all have been explained. Okay. So in order to answer those type of questions, again you need to remember this subnet calculations and all, and we can apply it there in the routing table calculations. Okay. You can visit our website for the commands in the videos. If you want to purchase other study materials like packet tracer files and other course guidelines, then you can email to us. Follow us on Facebook for further updates. Please do like, share, comment and subscribe so I can quickly deliver more videos on various topics. Hi, I'm Arun, your CCNA lecturer, and I have done my B-Eng and CTNS, which is a telecom related course, and Azure, which is Microsoft Cloud Platform, and CCNA for routing and switching, and then MCSA Microsoft Server 2016. Okay. And these are the contact details of mine. You can contact me via this or write to me. So now I have planned to deliver a complete CCNA course. Okay. So in order for you to follow, before that I wanted to tell you something. So before you started following the course, you need to have a brief understanding what are you going to do next. Because without having any understanding, just don't try to follow anything blindly. Because in mid you might feel like change of mind, or you might need to drop the course in mid, or else it might consume a lot of time from you. So having a good plan would save your time. So if you decide to make your career in networking field, CCNA would be a great choice for you, because Cisco has a very high reputation among all countries around the world. And most of the companies around the world are considering Cisco certs as a recognition. And Cisco networking certs has 3 steps: CCNA, CCNP and CCIE. CCNA is Cisco Certified Network Associate, and then Cisco Certified Network Professional. Among all these 3 steps, you just focus on the CCNA first. Every 3 years to 4 years, the Cisco syllabuses might change. So the CCNA 200-301 is the current syllabus, which has been changed on last February 2020. So if you spend more time, around 1 or 2 years, to only learn the CCNA, then again you need to focus and spend more time on learning for the CCNP and the remaining levels. Okay, so try to finish the CCNA course as soon as possible. Okay, and also individually CCNA itself has around 300-400 topics and key areas. So if you plan to learn each and everything from that, and then after if you try to do the exam, it's going to consume a lot of time from you. Okay, so these are the introduction I wanted to give you. So let me introduce you a shortest way to complete the course within 3 to 6 months of time for a part-time learner, and let me tell you how it works. For example, if you wanted to start swimming, you don't need to know about the molecular structures of the water, right? You just need to know the basics of swimming, and you need to dive into the pool and try it. Okay, that's the way you can figure it out easily and quickly. So likewise, you need to have a proper plan to attempt to learn the CCNA course. So planning is the very important thing here, and then you need to work it out. You need to practice a lot in order to make your planning succeed. So there are theories always. So all these theories, when you started learning from beginning to end, if you started from A to Z on each modules, you are going to get exhausted. Or when you started trying to learn again and again, or by repeating the same topics, later on when the contents are getting higher, you might start forgetting the previous ones, right? And also while learning theories, it might consume a lot of time from you. So let's keep the theory part aside. Next, we are going to focus mainly on the practicals. So just like that, you can't focus upon the practicals. You need to know what are you going to do with the practicals. So basics for the practicals are very important, and then you need some introduction of theories. So combine the introduction of theories as well as the basics for practical. You can learn the practicals very quickly, and you can practice it a lot. And after practicing the practical labs, you can simply understand the concept behind the theory, because all the theories which are going to include a lot of terms, key terms, which means like you need to know what is 802.1q, you need to know what is ISL, all these are terms. So likewise, you need to remember all terms. So it's really difficult to remember each and every terms. Without knowing the functions of the key terms, you can't figure it out easily. Okay, so that by doing the practicals and practical labs, you will simply remember what this actually does, and you can easily figure it out. Okay, and then you will focus on the theories in the questioning format of key points, so that it will be very easier for you to attempt the exam. A very high level of success is achieved over following this method in a short period of time for my other students. So I hope it might work for you as well. As I mentioned, the syllabus change, certain topics are not going to change. So you can simply figure out from the previous syllabus and the current one, we are still having the IP address calculations and the practical configurations, basics of packet tracers, which means the basics of configurations, and mainly VLAN configurations, routing protocols, access lists, and NAT, which means network address translation, and DHCP, dynamic host configuration protocol. All these concepts are not only important for your exam, but also for your on-job company environment. So when you join a company, you simply can manage by learning these practical labs. So if you plan to learn all of these on job, which means It could take around 5 to 10 months even. So just spend some time to practice these labs, and then you can easily catch the CCNA concept. So once after, when you are confident with these labs, you can go for the other small labs and subtopics of these labs, where I will point you with the key terms of theories as well. Most of the students are deciding to learn CCNA, but they are getting misdirected or they are dropping the course in mid just because of they follow the wrong path. So without knowing any understanding, if you try to follow it blindly, it's going to be a huge bundle for you, which is going to consume a lot of time from you. So just try to attempt the course tactically by learning these labs and get some confidence on these labs. Practice all these labs until you can create your own lab. Also, I will show you some real lab environments and devices and how to connect those, everything. And also we will simulate the lab environment by using the packet tracer software. So you can install the freely available packet tracer software into your system and you can practice the labs. By practicing, you can easily get the concept behind the syllabus and easily you can score in the exam. So this is a small introduction for you to clear the clutter in your mind. Keep checking the other videos time to time. I might include some other tips and tricks on how to follow the course and how to attempt the exam easily. In a later session, I will give you some other tips and guidelines regarding the exam. You can contact me on further details about the exam. Good luck on following this course. Hope you enjoyed the lesson. Good luck on earning your CCNA cert. Thank you.